Okay, in this lesson, we're going to talk about solving systems of linear equations using elimination. Okay, our book uses the term linear combinations. Okay, but the state of Ohio uses the term elimination. Okay, I like to think of it really as both. Okay, what we're going to try to do with this is we're going to take our two linear equations that we have, negative x plus 2y equals negative 8 and x plus 6y equals negative 16. Okay, and we're going to combine them by adding with the hopes of eliminating one of the variables, either x or y. So if you look at this first one, okay, what we'll do is we'll just add these two equations together. And when we add them together, the x's cancel each other out. Negative x plus x is 0. 2y plus 6y is 8y, and negative 8 plus negative 16 is negative 24. We now have an equation with just one variable. This is similar to when we did substitution. Once you substitute it in, you made an equation with one variable. Now it's just solving. Divide each side by 8, and you get that y is equal to negative 3. And once you know what y is in this case, you can find what x is by substituting back into one of the two equations. I would personally use the second equation because to me that's easier. You have a positive x, so you put negative 3 where y was, and then you solve this equation for x. So it's a little bit more difficult to solve. You're going to end up with x minus 18 equals negative 16. You add 18 to each side and you get that x is 2. And so your solution to this problem is 2, negative 3. And now what you should do is you should check, as always, you should check every solution that you get into the original equation. So negative x plus 2y, and then the question is, does that equal negative 8? So it's negative 2 minus 6, that's negative 8. It does equal negative 8, so it checks. Into the second equation, you're going to get 2 plus 6 times negative 3, and the question is, does that equal negative 16? Well, this becomes 2 minus 18, negative 16 equals negative 16, and that checks. So the answer, the solution to negative 3, works in both equations, therefore it's the correct answer. In this example, when we add our two equations, what happens here is the y terms disappear. Notice that you have positive 3y here and negative 3y. Those are going to cancel out. 11x minus 5x is 6x, and 1 plus negative 7 is negative 6. Divide by 6 on both sides, and you get that x is equal to negative 1. Once you know what x is, again, you got to plug back into one of those to solve for y. I would use the top equation because that's where my y term is positive. And when I plug in, I would do 11 times the negative 1 plus 3 times y. That's negative 11 plus 3y is equal to 1. Add 11 to both sides and you get that 3y is 12. Divide by 3 on both sides and you get that y is 4. So your answer, the solution to the equation, is negative 1, 4. Again, check it. I'm not going to show the check every time. I'll show it one more time. 11 times negative 1 plus 3 times 4. And the question is, does that equal 1? Negative 11 plus 12. That is 1, so it checks into the second equation. You have negative 5 times negative 1. Oops. Minus 3 times 4. Does that equal negative 7? That's 6 minus, 5 minus 12. And it's negative 7, and that checks. So again, we have a solution that works in both equations. Now in this next example, this is one where, if you look at it, if you were to add these, you would end up with 2x plus 7y equals 13. Now that equation still has two variables. So it didn't do us any good to add them together. So I'm going to get rid of this. Right? And what we need to do now is we need to do something so that we can get rid of either the x or the y. Right? In this problem, it would make sense to multiply one of the equations by -1. And what that would do, that would make the x terms have opposite coefficients, right? And that would eliminate the x term. Okay, so if we can get our x coefficients to be opposites of each other, right now they're both 1. Okay? An easy way to do that is to multiply one of them. I'll take the top one, multiply it by -1. Hey, remember you have an equation, you have to multiply each side of the equation by -1. And if I do that, I would get -x plus 3y equals 0. I'll bring down my second equation, x plus 10y equals 13. Okay? And now you're ready to add. Okay? And so now we'll add. This time the x's are gone. We get 13y is equal to 13. Therefore, y is equal to 1. Once you know that y is equal to 1, okay, we'll then go and find out what x is. Okay, go back into the original equation. Always stick it into one of the original equations. Okay, I'll put it into the first one. Doesn't really make any difference. Okay, x minus 3 times 1 equals 0. So x minus 3 is equal to 0. X is going to equal 3. And so your equation, or your solution rather, would be 3y. And so remember to check it. I'm not going to go through the check this time, but remember to check it. And now this fourth one, if you look at this one, if you were to add your two equations or combine your equations, you would not eliminate anything. So in this one, what we would want to do, if you look at the y terms, one has a coefficient of -4, and you have a coefficient of -4, and then you have a coefficient of -1. Okay, so what we're going to do is multiply the bottom equation by -4. Multiply that by -4. This will make the y terms have opposite coefficients. Okay, and then therefore then you would eliminate the y term. Remember what the goal is in elimination. That's why they call it elimination. We want to eliminate either the x or the y by combining, and that's why they call it linear combinations as well. We're combining the two linear equations to make just one equation, and we want to make one equation that has just one variable. So I'm going to multiply the bottom equation by -4. And again, you remember that you have two sides to an equation, so you multiply both sides of the equation by the same thing. This would make -8x plus 4y, and that would be -12. Bring down the top equation, 3x minus 4y equals 7. Now you're now ready to add. When you add, you get -5x is equal to -5. Therefore, x is equal to 1. Once I know what x is, and then find y. This case doesn't matter where you put it. You're going to end up with a -y, since both coefficients are negative here. So put 1 in for x. 2 times 1 minus y is equal to 3. So this is 2 minus y equals 3. Negative y is equal to 1. Therefore, y is negative 1. And then once you have that, you would check it. 1, negative 1. I have one more example left. So far, in every example we've done, either in the original two equations, if you just added, I remember the first one we just added and the x's went away. In the second one we just added and the y's went away. In the third one we had to multiply one of them by negative 1 before we added, and in the fourth one I had to multiply 1 by negative 4 before I added. Now on this fifth one, we have 2x minus 4y equals 8, negative 5x plus 3y equals negative 13. There is no easy number I can multiply either equation by to get rid of either x or y. Some people might argue that you could multiply the top by 2.5, and you could, but that is a fraction, and some people don't like fractions. So one option that you have with elimination is you can multiply each equation by something. So what I would do here is multiply by 5 on the top equation, and on the bottom equation, multiply by 2. What that does is get rid of my x's, as you'll see in just a second. Multiply the top equation by 5. Remember to multiply both sides by 5. And that would be 10x minus 20y equals 40. The second one, multiply it by 2. Negative 5x plus 3y. And that would be negative 10x plus 6y equals, this is supposed to be a negative 13, negative 26. So there are my two equations, which I will write on top of each other. 10x minus 20y equals 40. Negative 10x plus 6y equals negative 26. This time when you add them, the x's are now gone. You get negative 14y equals 14. Therefore, y is equal to negative 1. You need to find a value of x. So go back into probably the top original equation. You have 2x minus 4 times negative 1, and that equals 8. So 2x plus 4 is equal to 8. 2x is equal to 4. And x is equal to 2. And so once you have that, you can get your solution, which is 2, negative 1. And then you can plug into the original equation and make sure that that works. So in elimination, the whole point of elimination is to combine the two linear equations into one equation with one variable. And when you do that, you solve for that one variable, find that value, plug it back into one of the two original equations to find the other variable, and that will give you your solution.